Hello everyone, this is Tom from TutorBros. In this video we're going to go over the Pythagorean Theorem. Now this theorem must be important because it's the first thing the Scarecrow learned in The Wizard of Oz after he was given a brain. So the equation for the theorem is a squared plus b squared equals c squared, where a and b are the lengths of the legs of a right triangle and c is the hypotenuse. Put another way, if we take the two smaller side lengths of a right triangle and square them and then add them together, it will equal the square of the longest side. So it's important to note and worth emphasizing that this theorem can only be applied to right triangles. So please keep that in mind. Okay, now with that said, let's put this into practice. So we'll start with a triangle with leg lengths of, let's do 3 and 4 here. And then we will solve for the hypotenuse, and we'll label that, just for the sake of clarity, we'll label it C. Now we know that the hypotenuse is here because the hypotenuse is always going to be opposite the right angle in the triangle. And then for all intents and purposes, the A and the B, the leg lengths, are interchangeable for us. So if someone were to ask you which one is A, which one is B, it really doesn't matter at this point. So either this one's 3 and this one's 4, or vice versa. Okay, so we take these numbers and we'll plug them into the Pythagorean theorem and then solve for the unknown, which in this case is the hypotenuse. So we'll say that the 3 is our A term here. So we'll say that 3 squared plus, and then the 4 will be our B term. So that's 4 squared equals the hypotenuse squared. And we don't know what the hypotenuse is, so we'll just say C squared. Okay, and then we'll evaluate this. So 3 squared is equal to 9. So 9 plus 4 squared is equal to 16 equals still the unknown C squared. Okay, and then we just combine 9 and 16. So 9 16 is equal to 25. That equals C squared. And then to solve for C, or the length of the hypotenuse, then we just take the square root of both sides of the equation. So we take the square root of 25, the square root of C squared. Square root of 25 is 5, and the square root of C squared is just C. So 5, the hypotenuse, is equal to C. Okay, let's erase this first example here, and we will try another one with a slight variation. So we'll erase that, and then we'll erase the side lengths, and we'll start with a new right triangle. Okay, there we go. Alrighty, now this time let's say that we know one of the leg lengths. We'll say that it's 5, and we know the hypotenuse, and we'll say that it's 13. So the unknown here will be the other leg length, and we'll say that this one down here is B. Okay, so the procedure is still the same. We use the equation for the Pythagorean theorem to solve for the unknown side length. So we'll say that the 5 is our A term, so we'll say 5 squared plus, and then our unknown here is the B, or the other leg length, so we'll say plus B squared equals C squared, which is hypotenuse squared, which in this case would be 13 squared. Okay, so we do the same thing. We just evaluate what we know. So 5 squared is equal to 25 plus B squared. Still don't know what that is. And then 13 squared would be equal to 169. Alrighty. Now, in the previous problem, what we did was we added the squares of the leg lengths, but we don't know one of the leg lengths here, so we have to isolate for B squared first, and then we'll take the square root. So what we can do here to isolate for B squared is subtract 25 on both sides. So then on the left side of the equation, we'll just be left with B squared, and then if we subtract 25 on the other side, we have 144. So B squared equals 144. Last step, take the square root of both sides. Square root of B squared is B. Square root of 144 is 12. So the missing side length, or missing leg length, B, is equal to 12. Okay, Now you'll notice that the numbers we've been working with so far have all been positive integers. And when a right triangle has positive integers for all of its side lengths, those integers are known as Pythagorean triples. But sometimes the numbers that we are working with don't come out so nice and neat. A lot of times when we're using the Pythagorean theorem, we have to deal with irrational numbers. So let's take a look at one such problem. Forgot to erase these over here as well. Okay. All right, now let's say we know both of the leg lengths. We'll say that they are, let's just say 2 and 7, and then we will solve here. Okay, so we'll say that the 2 is our A term, so we'll say 2 squared plus 7 is our B term, so that's 7 squared equals C squared. So C would be the unknown, the hypotenuse here. Okay, then we evaluate. 2 squared is equal to 4 plus 7 squared is equal to 49 equals C squared. And then 4 plus 49 is equal to 53. So 53 is equal to C squared. Now we still take the last step and take the square root of both sides of the equation, but you'll notice here that unlike in the other problems, 53 is not a perfect square. So when we take the square root, so we'll take it on both sides, the square root of 53 is an irrational number. Now, depending on what your teacher or instructor asks you to do, they may say, find the irrational number and round it to, for instance, 2 or 3 decimal places, or they may just ask you to leave it in radical form, and that's what we're going to do in this video. So we'll just say that we'll leave the length of the hypotenuse in radical form. So we'll just say that the square root of 53 is equal to, and then the square root of C squared would be C. So the length of the hypotenuse in this triangle would be the square root of 53.